Okay, so we are looking at a particle, gives me the acceleration given by that equation right here. Okay, and I know at at the initial time of 0, it has a position of 8 meters and a velocity is 0. Okay, I also know that at 1 second, the velocity is 30 meters per second. Okay, so I want to find the velocity, or I want to know the time at which the velocity is 0, and I also want to know the total distance traveled. So I'm given an acceleration equation in terms of time. I want to go to velocity, therefore I'm going to use the kinematic equation A equals dv dt, okay? Where A is capital A, or the acceleration is capital A, 6 to the 2t equals dv dt. Now, this is a differential equation, okay? Mathematicians will tell you you can't separate the variables out of one part of the mouth, and then they'll say, well, that's how you have to do it to solve this. So what we do is we basically treat dv dt as like a algebraic equation, bring dt to the other side. So we're going to have a minus 6t squared dt equals dv. And what we do now is we integrate, okay? And I'm going to start, okay? I know that at time equals 0, my velocity equals 0. So I'm going to start at 0, 0 on both of these. And then I'm going to do something else that mathematicians get upset about, and I'm going to integrate to a variable, v and t, okay? But I'm going to do this because further calculus will be needed to be done. So I'll show you how to do that. We'll get an equation, and then we'll algebraically solve it from there. So when I do this, I integrate the left side, and again, a then goes to at, and 6t squared goes to 2t cubed. And I'm going to evaluate this from 0 up to t, okay? V on the other side just equals v, and I'm going to evaluate this from 0 to v, okay? So from this, plugging in 0, everything goes to 0. So I'm left with the idea that the velocity equals at to the 2t cubed, okay? So now I have an equation for the velocity as a function of time, as opposed to just getting the velocity at some specific time, okay? Now, I have this other variable a, which I'm going to go ahead and use the fact that when t equals 1, I know the velocity equals 30. So I'm going to plug in 30, and I'm going to plug in 1. Oops. T should be 1 cubed. And from that, I learned that a then equals 32. So now I have an equation for my velocity given as follows. So now my velocity equals 32t minus 2t cubed. So now I have an equation for my velocity as a function of t. Okay, so now in order to find, hey, what time does velocity equal 0? I'm just going to set velocity equal to 0. Okay, and then I'm going to solve for t. So that will be 32 minus 2t cubed. Now I'll have the trivial answer when t equals 0, v equals 0. We already knew that. Okay, solving it further, I can figure out that then my time equals 4 seconds. It also equals -4, but again, going backwards in time doesn't make a whole lot of sense. So the only answer that I really get is t equals 4 seconds. That is when the velocity equals 0. Now we want to figure out, hey, what's going on with the position, right? What's the total distance traveled? Now this is why I left the variables in there, because now I can do further calculus in that my velocity is equal to the time derivative of position. Well, I have my velocity as a function of time, like so. If I had not left the t in there, then I would just had some velocity at some specific time. This gives me the velocity as a function of all time. That's why we do it that way initially, okay? And I'll set that to ds dt. Now again, we'll use separation of variables, bring dt to the other side as much as the mathematicians don't want us to do it, but yet tell us this is how we do it. Bring dt to this side, leave ds over here. I'm going to integrate both sides. Now I know that the position is 8 when the time is 0. So again, I'm going to go on this side, I'm going to go 8 to some arbitrary s. And on this side, I'm going to go 0 to some arbitrary t. Again, going to a variable, not exactly something that mathematicians enjoy, but we're going to do this just in case we need to do some more calculus moving forward. I get a much more generalized equation that I'm looking at. Okay, so on the left side, I get 16t squared minus 1/2 t to the 4th. I'm going to integrate that from 0 to t. And on the other side, I'm going to get s, and I'm going to integrate that from 8 up to s. So plugging in 0 for t, it goes away. So I'm just left with, on the left side, 16t minus 1/2 t to the 4th. And on the right side, I get s minus 8. So now I have an equation for my position as a function of time. Now, what it's asking for is the total distance. Recognize that this thing comes to rest after 4 seconds. So it travels some amount in one direction for 4 seconds and then travels to a different position for the next second till I get 5 seconds, right? I have this flip from positive to negative velocity. So what I need to do is I need to figure out, okay, when t equals 4 seconds, for the first 4 seconds, my position is 136, plugging in t equals 4 into that. Then when t equals 5, and at t equals 0, it starts at 8, remember, right? So t equals 0 equals 8, t equals 4 equals 136, and then t equals 5, s is 95. Okay, so from 0 to 4 seconds, this guy travels 128 meters, starting at 8, going up to 136. And then from 4 to 5 seconds, okay, it travels 136. Okay, basically that'd be 40.5. Okay, because it goes from 136 back to 95.5. But it goes in the other direction. But again, I want the total distance, so it's not just a subtraction sort of thing. I'm adding these together. Okay, so adding those two together, I get a total distance of 168.5 meters. So again, with these problems, take a look at the equation you got, find a kinematic equation to figure out where you need to go, and then use separation of variables, different differential equation techniques to figure out exactly what it is that you are looking for.